Today's lesson is on type 3 equations. So type 3 equations is going to have more than 2 steps to solve for the variable. So you might see that there's more than one group of variables. So what we have to do to solve a type 3 equation is we have to collect our like terms. So our variables together and place all of them on one side of the equation, usually on the left side of the equation. So the left side of the equal sign. And then we move all our constants, which are all our numbers, onto the right side of the equal sign. And again, anytime you move anything over the equal sign, it is the opposite operation. If you're collecting like terms on the same side of the equal sign, then you do not need to do the opposite operation. And that'll make more sense as we do some examples. So let's take a look at our first example. So we have here 5x minus 3 is equal to 3x plus 14. So what we see here is we have two groups, both of them with x. So what we need to do is collect our like terms together, and we want to collect all our terms with x on one side of the equal sign. So usually we collect it on the left-hand side so that when we have our equation at the end, it shows as x equals to the constant. So our constants, therefore, would be moved over to the right-hand side. So I'm going to do this step by step. Let's work with the x's first. This one here, it's a 3x, and we want to bring this whole 3x over to the left-hand side. So because we're moving it over our equal sign, we have to do the opposite operation. We're moving the whole thing over. It's a plus 3x, it's a positive 3x, so then we have to subtract it over, like so. So what happens now, on our left-hand side, we have 5x minus 3x, which gives me 2x. And we still have the minus 3 to bring down. On our right-hand side, 3x minus 3x is 0, so that is now gone on this side. And we're left with plus 14, or just 14. Okay, so now we're going to continue to isolate x. And now this looks similar to type 2 equation. So we have this minus 3 here that we need to move over to the right-hand side. So opposite operation, we have to add 3. Add 3. Whatever you do to the left side of the equation, you have to do to the right side of the equation. So on the left side now, we're just left with 2x, because negative 3 plus 3 is 0. And on the right side, we're left with 14 plus 3, which is equal to 17. And last step, we have 2 times x, so the opposite of that is to divide. We've got to do it to both sides. 2x divided by 2 leaves me with 1x. So x is equal to 17 over 2. You can put that into a decimal, or you can leave it as a fraction. So 17 over 2, or 8.5 in decimal form. All right, so here is our next example. We have, on our left side of the equal sign, we have 6x minus 4.3 plus 3x. So looking at just the left-hand side of our equation, we have an x and an x here together. So we can collect those together because they're on the same side. So we're just going to show that 6x and 3x are on the same side of the equal sign. So what we can do first is collect that together first. So 6x plus 3x is 9x. And then I have minus 4.3. And then it's equal to 86.2 and plus 1x. Oops, sorry, that's a minus 1x. Minus 1x. All right, so now it kind of looks similar to the equation that we had just done previously, the first example. So because I want to collect my x's on the left-hand side and my numbers on the right-hand side, so I'm going to add the 1x, and I'm going to add the 1x. And notice how I add the x with the x. I don't add a 1x to the number. You have to keep the terms together that are like terms. So now on the left-hand side, I have 9x plus 1x. That gives me 10x. Minus 4.3 is equal to 86.2. The negative 1x and the plus 1x is 0. Okay, so I have my 10x on the left-hand side now, so all I need to do now is get rid of this negative 4.3. So by doing opposite operations, I'm going to add 4.3 to both sides. So on my left-hand side now, I'm left with 10x. Negative 4.3 plus 4.3 is gone. 10x is equal to 86.2 plus 4.3, which is 90.5. And now I just have to divide by 10 on both sides. And 90.5 divided by 10, you can just put that in your calculator, and we get 9.05. All right, so because we have on our left-hand side of our equal sign, on the left-hand side we have a 6x and we have a negative 2x. So we can collect that together. So like I had said before, you can collect it together 6x minus 2x, or you can collect it together as 6x plus negative 2x. Either way, you're still going to end up with the same answer. So 6 minus 2 or 6 plus negative 2, you're still going to end up with 4x on the left-hand side. All right, so because they were both on the left-hand side, we can just collect them together. And we're still left with a negative 5 here, like this. And then on our right-hand side, we have 7 plus 1. 7 plus 1 can be collected together just like adding them together. 7 plus 1 is equal to 8. All right, so here we are now. It looks like a type 2 equation. So we have 4x minus 5 equals 8. So now we're trying to isolate x. We want x to be on the left-hand side. We want everything else to move over to the right-hand side. So we always do our addition, subtraction, opposite operations first. Anytime you're moving it over the equal sign, it's the opposite operation. So because it's a negative 5 here, we're going to add 5. And you have to do it to both sides. All right, so negative 5 and plus 5, that's gone here. And we're left with 4x is equal to 8 plus 5, which is 13. And last step now is we have to get rid of this 4 because we want x by itself. So it's 4 times x. The opposite of that is to divide. You have to do it to both sides. All right, so at this point, you can leave it as x is equal to 13 over 4, or if you put that in your calculator, you will get your decimal answer, 3.25. All right, so our next example here, we have 7x minus 3 minus 2x, and it's equal to 8. So we can collect some like terms on our left-hand side. We have a 7x and a negative 2x that we can collect together first on the left-hand side. So 7x minus 2x, that gives me 5x. So all I've done is collected these two together. And I can do that because they're on one side of the equal sign. And then I have minus 3, which is just right here, and it's equal to 8. All right, now There's nothing more to collect on either side, so now it's time to isolate x all by itself. So we have a negative 3 here, so the opposite of that is to add 3, but we have to remember to do it to both sides of the equation. So we end up with 5x is equal to 11. And last step, we just have to divide by 5 on both sides. So x is equal to 11 over 5. And if you put it into decimal, we get 2.2.